The next thing we want to look at is the starter itself. If we can demonstrate that all proper voltages and grounds are applied to the starter and it still doesn't crank, then we have a bad starter. But before we get to that, let's talk about the common strategy that many people use to test their starter. This test is the one where they use the headlights as an indicator of a starter fault. To do this test, first turn key to position 2 or the on position. Let the fuel pump finish priming and then turn on your headlights. From there, turn the key to crank and watch intently on the brightness of the headlights. If the headlights dim, that means that the power is successfully getting to the starter. The headlights typically dim momentarily with a car that successfully cranks. If the headlights dim but you don't hear any cranking, this is usually enough to prove that the starter is bad. There is, however, one caveat. This is in the rare case that you have an even bigger problem where your entire engine is seized. This is where the starter tries to turn the engine with all its strength but the engine just refuses to rotate. A final test is where you try to turn the engine over by hand using a breaker bar on the crankshaft pulley bolt. If it turns, then you can be certain the starter is at fault. Now let's go back to the other case during the headlight test. Let's say the headlights stay the same brightness. For better accuracy, let's even put a voltmeter in the cigarette lighter port while in key position 2. Let the voltage stabilize as all the different instruments power on. Now as we crank, see the voltage stay exactly the same. This shows us that the electricity is not flowing through the starter. In other words, this is an open circuit fault where something other than the starter can possibly cause this no crank condition. For now though, let's only focus on the starter. Let's try to prove that the open circuit is internal to the starter and that it still needs replacing. For this test we will have to prove that the starter solenoid is getting 12 volts and also that the engine grounding is strong and free of resistance. Get a voltmeter and attach the black negative lead directly to the negative post of the battery. Make sure you use the negative post of the battery instead of the chassis to avoid any confusion that bad grounds in the car may cause. You will have to use extension jumper cables for this, as BMW likes to put their batteries in the trunk. Now with the positive red test lead in hand, we can begin testing. For a sanity check, let's make sure the B+ terminal has 12 volts. The voltage at this terminal is what provides the starter motor the bulk of the energy to crank it. This terminal is a direct, non-fused connection for the starter and alternator to the battery. If you don't see voltage here, then you have some big problems. This vehicle was likely in an accident and the battery safety terminal is worth inspecting. Next, let's look at the input to the starter coming from the EWS unit. Using the correct Allen wrench, remove the cover to the electronics box located in the rear driver side of the engine bay. Locate the X6011 connector. It is a 8-pin connector where pin 1 is of importance. Pin 1 is a black wire that is the start signal to the starter solenoid. Backprobe this wire using your red test lead. Now attempt to crank the engine. 12 volts should show up here. If no voltage appears, then you successfully proven that the issue is something else and that the starter is not at fault. This is because you proved that the voltage never even makes it to the starter. But what about if you do see voltage? If you do see voltage, then you are one step closer to proving that the starter is at fault. We will now test if the issue is simply due to bad grounding. To do this, press your red test lead into the metal body of the engine as you crank. An easy location I like to use is the exposed metal below the oil filter cap. You can use anything metal though. As you hold the lead there, have someone else crank the engine. The voltage should remain close to 0 on an engine with good wiring. If this is true, and the 12 volts from before still exist at connector X6011 while cranking, then you have proven that the starter is at fault. However, if you see the voltage goes up on the body of the engine while someone else is trying to crank the engine, then that concludes that you have a bad ground somewhere. You will have to work your way back to find out where the bad ground exists. Do the same test again, but with the red test lead on the chassis of the car. If the voltage here stays low as you crank, that means the engine ground strap is bad. Replace the engine ground strap that is bolted to the passenger side of the engine. In the rare case, let's say the voltage goes up even when you measure from the chassis of the car. This is where you have to go to the trunk of the car and inspect the cable that connects the negative battery terminal to the chassis. Measure voltage drop across it as you try to crank. This cable can fail with too many bends after battery replacements.